Hi, this is Manit Kheda, and this is my task. This is my helping video for task 1.3D in object-oriented programming. In this video, I'll be exploring the basics of data structures and algorithms, which most of us students will have in next trimester, and explaining just the basics of it. So let's just start. Like, what exactly is data structures and algorithms? We can split DSA into two parts: data structures and algorithms. Like the name suggests. So, data structures are basically containers where you store data, and algorithms are like different mechanisms to access the data or sort through the data or insert into the data structure. And different algorithms, like you have to have if you have a specific data structure, uh, it and you have a certain algorithm with that data structure that you're using on that data structure. That algorithm can have a different time complexity to actually either access or change that data structure. So different, it's basically like mix and matching. Different data structures have different you know the different algorithms have different time complexities for different data structures. And why is it necessary? Well, basically, in order to have code that is fast and simple, we used this like different combinations of the data structures and algorithms as per the need of the code. And why does this matter? Well, because it improves performance and it improves predictability, and it has usually cleaner designs as well when we write code. So, big O basics. Basically, there's like a graph which showcases the different time complexities, the different growth shapes, and in that graph, which I'll show you right here, basically the O of one is the fastest at is the fastest time complexity, and O of n factorial is the slowest one. Um, and again, it's like basically to find the data that we're looking for, which we call like the n, um, to like actually sort through it or whatever we have to do. The O of one is the fastest; it finds it like the quickest. If I explain it in terms of, I'll explain in terms of arrays. So in arrays, like to access, because we have indexes, right? An array, it's like multiple boxes together, and we start like from the zeroth index till the n minus the nth index. Sorry, n plus one index. Yeah, to the n plus one index. And so accessing um, the array, it's an O of one time complexity. That basically means like if we want to find like, it's because we have indexes. So if we want to find the fifth element, um, we go to the fourth index, right? So it's pretty quickly. I mean, it's a O of one operation. It's quite straightforward. However, if we want to insert um, something that is uh, an O of one operation, if we're replacing something. So for example, if we are replacing the seventh index in a list of 10 elements, so that's like the eighth element if we're replacing. Yeah, so if we're replacing that, so it's quite straightforward. Like we can just like change the value of it. So we can just put uh, the array and then 7 equals to something, whatever we're changing it into. However, if we want to append it, then it's an O of n time complexity, because we have to first create a new array with one index size greater than with more, basically one element greater than the previous array. Then we have to loop through that means go through um all of the elements, which is basically O of n, because like we're going till the nth element, right? So we loop through all of them, and then we copy them, and then we paste it into the new array, which is empty. And then in the n plus 1th element, we just place the new what's it called, the new value that we want to append. So basically we first have to loop through the entire thing, and then we have to copy it and paste it. So that's why it's an O of n complexity. It's a linear thing. Basically we go through it by one by one by one. um Deleting is also an O of n, because again, if we remove an element from between, then we have to basically shift all of the other elements which are ahead behind. So we have to again sort, we have to go through till the nth index, and then we have to bring it back. You know, it's the same thing. Let's take a look at next the other data structure, linked list. There are many more data structures, but to be honest, like they are much more complex, and how their interaction with data structures takes place is also very complex. So I just took two basic examples to explain, so that it can gauge somebody's interest in this. Linked lists are like, they don't have indexes, so it's like, imagine boxes in a line, but it's not, you don't start counting 0 1 2 3 4. It's instead like it contains value and pointer to the next node in the sequence. Um so if we the acts because like so basically, if we have to access um a specific entry, specific data, then it's O of n, because you have to linearly go through the first one, then the second one, and the third one. There aren't any indexes like in arrays, so we have to just go through it all. So x, and then till we find the specific data that we're looking for. So it's a linear process basically. But if you want to insert, it's an O of 1 if you have the reference to the node that you want to insert around. And similarly, if you want to delete as well, then also it's O of 1 again if you have the reference to the node you want to delete around. And that's basically linked list. Again, we'll learn more about this in next trimester, but those are the time complexities for the linked list. Now finally, the comparison between arrays and linked lists. So if you want to access something quickly, then arrays are preferable. If you want to insert or like basically change the structure around, then linked list is again quicker. um, Again, appending many items, both are pretty much okayish. And that's basically the entire introduction to data structures and algorithms. Thank you for watching.